Let's discuss object-oriented programming or OOP in this video. So as the name implies, OOP considers the tasks performed as objects rather than the procedural code. Now when I say procedural code, what I mean is we inform the computer to do task 1, then task 2, then task 3. So the computer is going to follow things line by line. So the main advantage of using OOP is that every object is like a small function with the code and the structure, which allows it to have some methods and attributes. Now in the Python language, the concept of OOP is very structured and it has the following components. So we have the class, object, the method, inheritance and polymorphism. So let's discuss these topics one by one. Now when it comes to class, a class is a user-defined blueprint of the object to be built. It contains all the attributes and methods of the object. Now for example, let's say we want to create a citizen class. Now if we decide that this class should contain attributes like name, age, country, we can define these attributes inside the class. So let's switch to a Jupyter notebook and see how we can define the citizen class. So the first thing that we need to do whenever we want to define classes is to give the keyword class. So you can see that this keyword has highlighted in green. So we know that it's a very specific keyword inside Python. And one other thing that you would see is that whenever we define a class, we give the first character as capitalized letter. Till now, whatever we have seen, we have always seen that whenever we give the variable names, we used to keep everything in small letters. So when you're defining classes, this is one thing you need to follow, or which is also known as camel casing. Now inside the citizen class, the first step that we need to do is we have to give it the initialization. So we are going to define another class in here, and this might look a bit odd, but try to follow this thing. So first thing we need to do is we have to write double underscores init double underscores, and we'll mention self comma. Now the different attributes that we wanted to give. So we wanted the citizen class to have the name, age and country. Now inside this we have to mention as self dot name is equal to name. Similarly, we'll say self dot age is equal to age, and self dot country is equal to country. So these are the properties that we want to define inside the class. So now let's execute this. So we have our first citizen class. Now let's try to understand what have we exactly done here. Now all the properties of the citizen class are defined in a method called as init. So here we have written the function, right? Def of init, and we have given this particular thing in the braces, name, age, country. Now the self here indicates the class itself. So when I'm writing here self and I've written here self.name, self.age, what it is telling Python is all of these things belong to the class citizen itself. So that is the importance of the self keyword. Now the next important thing that we need to do is we have to give the instant attributes which should be different for different objects. What I mean by that is whenever we need to define, I would have to use the citizen class, I would be defining it in different objects. So before we move on to objects, let's actually talk about the attributes. So any attribute defined inside the class and before the init would be called as the class attribute. Okay, and it would have the same value for any instance. Now, so before we dive deeper into that topic, let's actually discuss the object. Now, when we say object, an object is an instance of the class. Now we have created a class called citizen. Now we can create objects using this particular class structure. So let's actually quickly create a class out of this. So let's say I write something like citizen1 as my first object. And this citizen1 will be an object of the citizen class. Now we know that the citizen class needs name, age and country. So we have to give these details to create this particular object. So we'll say Tom. Let's say the age is 25 and let's give the country as US. So this is how we have actually created our first object. Now, whenever we are creating an object, every object would has its own identity, state and behavior. So now let's discuss these terms: identity, state and behavior. So whenever I say identity, what identity means is just that it's a unique name given to that particular object. So in our case, this object has the name citizen1. So it's going to be unique for different objects. So that is the identity for that particular object. So that is how you're going to distinguish between various objects. Now, second term that I used was state. Now the state refers to the properties or attributes of the object. And thirdly, the behavior. Behavior always refers to the methods or the functions of the object. Now let's say we have created this particular class citizen1. I mean the first object of using the citizen class. Now if I want to access the attributes of the created object, what we need to do is we have to call in using the dot method. So I can simply say citizen1 dot, and as soon as I hit tab, you can see that it's telling me it has the attributes age, country and name. So let's actually call one of these. So let's say I called age and I run this. It is going to give me the value of 25. Now, this is how you're going to create different objects. Second thing that we have to discuss is, let's discuss about methods. Now a method is a function that defines the behavior of the object. Now let's say we want to add the method to our citizen class. So for example, the citizen can talk. So let's redefine our class with the talk method. So what I'm going to do is I'm going to grab the citizen class from here and let's just copy it. And below this, I'm going to define another method. So we had our init method. Just below that, I'm defining the talk method. And the talk method, just like above, we have to say talk of self. And inside this, let's just give it a print statement for now. So let's say, so we'll say, hi, my name is, and let's grab whatever name of that citizen is. So for doing that, we can write self.name. And since I'm going to write this particular thing, I'm going to take self.name. Let's make it a f string so that we can access those variables. So you can see as soon as I have given the f over here, this became as a variable. So we can get that information from there. And let's also write like this. So let's say the citizen says I belong to the, and we'll give the country. So we'll give self dot country. So now let's execute this so that our citizen class is updated with the talk method. So now let's redefine our citizen1. So all we need to do is grab this thing and we have to re-execute this particular statement. Now let's try if our method object has the talk method. So we'll say citizen1.talk, and because we want this to be printed, we are going to execute it giving the braces. Okay, it's working correctly. So this particular information Tom 25 and US, that is being called correctly inside the talk method. So let's make it a little better over here. We'll just give it a comma. All right. Now, next is what you have to remember over here is whenever you're using the methods, always remember to give those braces. Please don't forget this, because if you don't give the braces, so let's actually see what happens. So if I just write citizen1.talk and execute this, you will not get an output. It's just going to tell you that it's a method of the citizen class and it will give you the memory location. But we actually want to see this, so we have to give the braces and execute it. Now let's actually see an example of the class attribute. I had mentioned that when we define an attribute before the init, we are going to call it as a class attribute. So let's actually give it an attribute. So let's say that the class attribute is planet and the value is Earth. So now let's just copy this. And inside this, what I'm going to do is, before the init, I'll just mention planet is equal to Earth. And now let's re-execute this thing. So let's create two objects. So let's grab the citizen1 from above. And also I'll create another citizen2. And this time citizen2, let's take the name as, let's say Sally 25, and let's keep it US. So now we have created two objects using the same class citizen. So now let's check for the attributes. Specifically, let's check the class attribute planet that we just created. So citizen1.planet, this is saying as Earth. Similarly, if we see for citizen2, we are going to get the exact same result. So this is a class attribute. Now, so here we can see that the examples like name and age are the instance attributes, whereas the planet is the class attribute. So now let's discuss one of the most used concepts in OOP, that's the inheritance. So inheritance is a way in which one class can inherit or get the attributes and methods of another. Just like what we understand in English, when we say inherit, we are going to get something, right? So the class which gives the attributes and methods is known as the parent class or the base class, and the class that inherits the attributes and methods is called as the child class or the derived class. So let's create a child class called resident, which will inherit the attributes and methods from the citizen class. So citizen class is going to be our parent class. So let's see how we can define a child class. So we're going to call this as child is resident, and inside the braces, now instead of self, what we are going to do is we are going to write the parent. So I am going to mention as citizen over here. Okay, and just like before, we have to give the initialization. So we'll give def init underscore underscore all the values that we wanted. So we have name, age, let's give address, the country that was going to be derived, and let's also give a zip code. Okay, now inside this we know that address and zip code are something that is not present in the citizen class, so we have to define it in the resident. So let's give this information. So we'll say self dot address is equal to address. Next we have self dot zip code is equal to zip code. Okay, and the most important thing that we need to do here is we have to invoke the init of the parent class inside the child class. So we actually have to say something like this. We have to mention citizen, which is the parent class, dot underscore underscore init underscore underscore, and we know in this we have to get the self, name and age, and also we had the country. Okay, so this is one important thing that you should remember, that you need to invoke the init of the parent class inside the child class itself. Now next thing is, let's also give it one other method. So I'm going to call this as resident details, and inside the resident details what I'm going to do is I'm going to call all the information just to check whether the parent class and the child class, the inheritance worked correctly. Okay, so I'm going to print out the information. So we'll say print, let's give it the string, name of citizen, and write self dot name, and let's call all the information just like this. So I'm going to copy this line, and give it the age. Next let's go for the address, Next, the country. Next, let's take the zip code. Okay. Okay, we'll take only these details. Let's drop the last line. All right. So here we can see that we have an init class and we have the resident details. That's another method. So now let's actually run this thing and let's define a resident and check whether everything is working correctly. So let's say resident 1. This is equal to resident, and this time let's change the person. So let's say John. Let's say the person stays in New York City. US. And finally the zip code, let's just take a random one. Okay, so now if we run this, Python has executed this particular statement. Now all we have to do is check whether everything is working correctly. For that we have created a resident details method. So let's just call that method and see if everything is working correctly. So we'll say resident1 dot resident details and we run this. Okay, it's saying resident details takes 0 position arguments, but 1 was given. So let's see what we have actually done. Okay, so because this is something that is part of the resident class, we had to actually give the self keyword. So let's rerun this. All right. So once we corrected and put the self keyword in here, you can see that all the details have come correctly. That means the inheritance is working correctly. Now, finally, let's discuss about the polymorphism. Now, polymorphism is a way in which objects can share methods and attributes, allowing them to take many forms. So that's how the name has come, polymorphism. So it has many forms. Now polymorphism enables the developer to reuse the existing code. So basically we have this principle called as dry, do not repeat yourself. So based on that particular principle, polymorphism is based. Now let's create a new class for the different shapes like cylinder, square and triangle, and let's create our own classes and see how we can do polymorphism. So for this particular exercise, what I'm going to do is I'm going to calculate the area of the cylinder, square and triangle. So we have to import extra one other thing, that is I need the value of pi. So we can simply say for the importing of the pi value, we can take it from math. So we'll say from math, import the value of pi. So this is one thing we would need. Now let's create the class objects. So we'll say class. So this is what I meant when I said camel casing. You can see in my cylinder I have the M and the C as capitalized. Now next important step is the init method. So def init, inside this we'll give, because we are going for cylinder, let's go for the radius and the height. So self dot radius and self dot height is equal to height. Finally, we wanted the area, so let's create this particular method. I'm going to call this as my area. Let's give the self keyword in here and let's just print out the area. So we'll say print, this was 2 times pi times self dot radius times self dot height plus 2 times pi times self dot radius squared. So this is going to be the cylinder class. Similarly, let's take the triangle. So I'm going to copy this and let's make the edits in this particular thing. So I'm going to create the cylinder, triangle and square. So let's actually copy it twice. And here instead of cylinder, let's just make this edits. So I'm going to call this as triangle. For the triangle, we would have the base and the height. And for the area, we know this is going to be base times height divided by 2. This is going to be the triangle class. Similarly, let's define the square. And for square, we know we need only the side information. So let's actually edit these two things. So now we have these 3 classes. Now you can see that I've kept the area method the same name on purpose. Okay, so we have each of them calculating the area. So what we are going to try out is we are going to create a new function which takes an object and then prints out the area of the respective object. So for that, let's define our object. So we'll say, and I'm going to call this as calculate area. So I'm just going to say calc area, and it's going to take in an object. So let's say object 1. And here what it does is it takes object 1 dot the name that we have given is my area. It's going to call on that particular method. So this is the function we are going to use. Now the above function, this calc area, is the interface which we will be using to print the area of the respective object. So now all you have to do is create our objects. We have a classes. Now let's create certain objects and test it out. So the first one is going to be my cylinder. Just going to give some random numbers. So let's say 10, 10. Similarly, the triangle. This requires two numbers, so let's continue giving it 10. Finally, the square. So it's my square. This is equal to, and this requires only one number, so we'll just give it 10 for now. So now we have these three objects. Let's test out our calc area and print the area. So all you have to do is calc area of the object name, and we have given the name exactly like that. We have sent my cylinder. Similarly, we'll say my square and my triangle. So you can see that I didn't have to redefine the calc area. What we actually did is we reused the code block of calc area repeatedly, and that is how our polymorphism works. So this is what I have for you in this video. Thank you.